right, so people walking in right now. My name's Alan Underwood. Again, I'm coming through the speakers, it sounds like, right? Yeah, everything's good? All right, cool. So I do a podcast called Coding Blocks. Been doing it for about 6 years with 2 other guys. It's just the 3 of us. We don't do interviews. We basically just talk about all the stuff that you guys probably talk about when you're at work, right? Like, man, there's this problem. How do we solve it? What do we do, right? And it's 3 different perspectives on that. And so that's what we do, right? We've got a decent following, and this is my first time actually coming out internationally and speaking, so this is kind of fun. I'm a Microsoft MVP. I feel kind of bad because I saw people put that up on their screens. I didn't have the logo, so I'm an MVP, and I've recently, I say recently, within the past year, gotten into streaming stuff. So, and we'll talk about why here in a second. So again, everybody that came in, if you want a chance to win the AirPods, tweet, put a photo, do something funny, whatever, just make it fun, and put NDC London on there, and you have a chance to win the AirPods after this talk. That's a fail. Really? See, this is what happens when you buy nice technology to come do a talk.
It's the one thing you didn't test, right?
No, I did. When I was staying up till 2 o'clock in the morning every night, I was sitting there with the clicker doing it all.
Were the batteries down there?
No. You could apparently plug this thing in for 2 minutes, and it'll do its thing. You gotta be freaking kidding me. That's so frustrating. $90 paperweight. Yep. And if this doesn't work, I'll be fine, because I'll just come over here and click the keyboard. You know what it is? I'm not on the PowerPoint. No, that's got to be. Whatever. I'll walk back and forth. Okay, so the first slide, the reason you're wondering, why am I talking about donuts, right? So has anybody ever made donuts at home before? Anybody? Not many, right? It's actually a chore, right? It's a fairly intense process. And I've got kids, so this is what everything looks like in my house at any given time, right? And when you do donuts, there's a lot of flour, there's a lot of things. So this is what it turns out being. But that's not the important part. What I want to get at here is it's very much a batch-oriented process. You do something, you finish that, then you move on to the next step. So after you get the dough all set up, made out, then you got to roll it out, you got to cut it, you get all these things cut out, you roll the dough some more, and you keep doing this, right? After that, you take it, you drop it into the fryer, which is only a minute per side. That was kind of shocking to me when I first did this. For whatever reason, I thought it was a longer process. And then the glorious part, right? You put the stuff on there that people actually want to eat. After that, you put it in the oven, you bake them, right? That's the way that you do things. Even if you're doing cookies or anything like that, it's very much a step-by-step process, and you can't do the next thing until the previous one's done, right? And that's very much how batch-type things are. Well, I think when I first started getting into Kafka and Streams, I had gone into a Krispy Kreme because my kids saw one, and they're like, Dad, we need donuts. So, of course you do. So we went in here, and I'm watching this thing, and it was fascinating. So I've got a little video here. You got it. That's unbelievable. Everything goes wrong during the demos, right? Well, bear with me. It's like a 1-minute video, but it will absolutely without it, it's not going to be all that interesting. Man, it won't play. It doesn't even give me the button to click it. There we go. All right, so check it. But it's not showing. It's not showing up there. It's showing here. See, that's mine. That's not what's up on the screen.
How many presentations have you guys?
Just that one.
Just the one.
Yeah, just that one. Can I go out of presenter mode? Okay, check it out. I'm going to play this thing here, maybe. That'll work. And then you should be able to see it. So let's talk through this. So the way things work at Krispy Kreme is, the way the dough's made is it's actually squirted out of these nozzles, right? So this stuff's all happening at the same time. And if you've ever gone to a Krispy Kreme that has this, it's really cool. And then, instead of you actually doing things, as these things come down the conveyor, they get thrown into these things where they let the stuff rise, right? So this is all happening concurrently. Now, when it's going through the fryer, it actually swims down through a pool of this stuff. And so you have things happening in parallel the whole time. You're no longer, there's not somebody back there rolling dough and all that kind of stuff. This is all continuously going, right? So as dough's being made right now, this stuff's also going down the stream, and it goes through this wall of amazingness. I mean, that's pretty awesome. So as you can see, this is, like, when I was looking at this, I was like, oh, this is amazing. They took this problem where people actually had to go through stuff, and they turn it into this parallelization, right? Like this thing where they have multiple streams of this working. And the only thing that's stopping them from doing more is the amount of space that they have for having these things set up, right? So let's get back in here. And now that we've got the one thing out of the way that could potentially go wrong with this. All right, so now let's talk about what probably most people are familiar with, which is, I mean, I've been a developer for probably about 20 years, and this is kind of the way the world's worked for a long time, is you have your database, right? Like, everybody's familiar with this. All your data's going in there, and all of a sudden you need to start getting data, and you start these processes at midnight, right? Because that's when everybody's asleep, nobody's on the system, so you start pulling data in. So you grab some stuff from the data warehouse because you need to enrich your customer information, right? Then, let's say that you want to go get some social data. Facebook has all your information, right? So you grab stuff from Facebook because you want to enrich your data even more. Maybe you want to find out buying patterns, the stuff that people are looking at. So that happened 2 hours later because you needed to wait for your load from the data warehouse to finish, right? And then at 3 a.m., because Facebook has all your data, you're going to go get some more, right? And again, you're waiting until the previous one's done before you go on to the next one. Then after you get all the data in, you're going to start transforming that. You're going to put that data together, you're going to try and make sense of it, and you're going to use it at some point. And then maybe you're going to start generating reports after you've put all that data together so that the next morning when people come in, they can start working on their day job, right? On the previous day's data. This is something that I would venture to say most of you are familiar with. I mean, this is kind of how business has gone for a long time. And then you pray that by the time everybody gets in, everything's gone right. And not one of these data loads failed, because that inevitably happens, right? Oh, the data warehouse was down. Oh, Facebook, their API wasn't working. Whatever, right? This is basically what happens. And if something did go wrong, sorry, hopefully we'll have it up this afternoon. Maybe. Maybe it'll be the next day, right? So this is kind of the standard way that everybody's lived for years. Man, this is really squeaky. Anybody that's ever worked with SQL Server and done any data transformations ETL, this is a small, little view of what that can look like. And it's very much a linear thing, right? Like that thing at the top has to finish before these next ones kick off. And then this next one has to happen before those go, right? And you can see the things turning green, some of them yellow while they're working, whatever. And this is standard. And this is the way that we've worked for years and years. So what's wrong with it? Maybe nothing, right? If that works for you, you don't have data that's killing your systems, there's not too much coming in, whatever, maybe that's fine, right? And maybe if you only care about getting that data a couple of times a day, maybe that's fine too, right? Like you don't care about data coming in all the time. But what if it's taking too long, right? Maybe this is your primary database and everybody's using it, right? How many of you use a database server and have abused it beyond what it's supposed to be, right? Like it's a transactional database, but now it's your reporting server, it's your warehouse, it's your web front end, it's all that. Like that's what most people do. Because what I like to say is when you have a hammer, everything looks like a nail, right? And that's basically what people treat their databases like. And it starts slowing down, right? You might have I/O constraints. The disks aren't fast enough, or you have too many things coming in, or you have transactions that are blocking other things, right? So the locking contention. Let's say that thing with the data warehouse happened. You didn't get it in because it wasn't ready at the time, and now all your processes get pushed back, if not canceled for that night. And what if instead of every day the data being fresh enough, you say, no, I need my data closer to real time, right? Like maybe you're working in the security realm, and if somebody does something, there's a breach of your system, you don't want to know about it tomorrow because you just gave somebody 24 hours to take over your network, right? You want to know about it soon, like as fast as possible. And I work in the security space, so I'm always dealing with a lot of data. And here's another thing, and this is sort of on the edge of what this problem is. What if, where you did all that work, those SSIS packages, all the transformations, the ETL, that's in your database, but another department needs that same data, right? You're putting together accounting data. And what if you're doing a process that's slightly different than the other department? All of a sudden, you guys aren't in sync, and you don't know why you're rating customers higher and they're rating them lower, right? Like there's some sort of mismatch there. And so that's one of the problems that happens when you start doing this, is departments just sort of silo themselves. So this is where Apache Kafka comes in, and it is Kafka. I used to call it Kafka, but I've been corrected. When you do a podcast and your audience is developers, we like to tell each other that they're wrong. So I get that a lot. So Apache Kafka it's a distributed event streaming platform. And the crazy part about that is when you say it, nobody understands what it means. The cool part is it can handle trillions of events per day. And don't take my word for it, Microsoft does it with Office 365. They're actually using a cluster of 10 Kafka servers using HD Insight, and they've got an article write-up about how much they're doing, throughput, size of data, everything. Like, it's amazing stuff. Links in there. Oh, and by the way, all these slides will be available. I'll go back at the end or whatever, and I'll give you the GitHub page. So they do this. It was originally created as a messaging queue. So if anybody's worked with RabbitMQ or anything like that, data comes in, gets popped off the stack, and then goes on, right? The big difference between Kafka and something like RabbitMQ is this is a persistent, highly scalable, and fast data queue. So that's where it comes in. It's also known as a distributed commit log. So when a lot of people come from the database world and they start working with queues, they have a hard time wrapping their head around the fact that this isn't data that you query, right? As data comes in, it just goes on top of each other, right? Every message that comes in just keeps stacking. If you want to go find data in that, you basically got to go through the entire commit log of it. And that's what this is, right? So it was open sourced by LinkedIn in 2011 because they have a lot of data. They're kind of like the Twitters and the Facebooks of the world, right? Like they have a huge amount of data coming in. And what's cool is when they started seeing this, because they made it hyper fast and distributed, they're like, oh, maybe this is more useful than just another queuing system. We can use this for real-time streaming because it's so fast at putting data in and getting data out. So what I want to tell you is that if you can think of Kafka as like your backbone for things to talk to each other, that whole problem where I said that this database has information over here that could benefit this department, right now the way that people hook that up is they create another SSIS package, right? And then they set up on a schedule to push things over. What if, instead of that, you have data go through Kafka and everything can just subscribe to the data it cares about? And then that way, when new data comes in, you have access to it immediately. And everybody has consistent access to it, right? So what about a demo? I'm sure everybody wants to see what I'm talking about, but let's not get ahead of ourselves. So here's the thing. It helps to understand a little bit about the Kafka or the K-streams, the Kafka streaming world, because there's a few different parts to it. And just as a heads up, there's a lot of streaming technologies out there. You've heard of probably Apache Spark, Storm. There's a ton of things, right? So why go with something like this? The key is this. I'm sure you all work in places where, let's say that I think a lot of people here are .NET developers, right? So you have .NET, you're probably using SQL Server and then some other front-end technology, right? If you tell somebody, hey, I want to add something to the stack, there's a lot of acid reflux that comes along with that, right? Like, I don't want to operationalize this. Who's going to run it? Who's going to do this? So that's a problem. And if you start going into things like Spark and all those, there's a lot more infrastructure you have to stand up. It's not just that, right? When you do Kafka, you get this with it. And that was one of the driving factors behind me going with this stuff. So with this, let's talk about it a little bit. So in Kafka, you have producers. It's pretty easy. Those live down here at the very bottom level. All they do is put data into a topic or the queue, right? That's it. You have consumers. They simply get data out of something. They subscribe to it. So if you have a topic out there, anybody that cares and has access to that topic can subscribe to it. So anytime a new message hits it, they're told about it. That's how that works. So now you have streams applications. And I want to point out here that your productivity goes up as you come up here because the code's easier, right? Your flexibility goes down as you're at the top because obviously as you add more abstractions to things, the lower level access to those other things that you need disappear, right? It's the same type thing when people do like Xamarin Forms. Like you can do some amazing stuff with it, but if you need to start reaching beyond what they've done there, you no longer can use those abstractions. You have to go straight to iOS or Android, right? Same type thing here. So in streams applications, in this middle here, they have what's called a K-stream. And more or less, those are Java applications. And they are really producers and consumers because the way those applications work is they will subscribe to a topic and say, hey, I care about when data comes into this, right? Like maybe it's my accounting information. When data comes into it, it's going to be a little application that runs some sort of business logic, and then it pushes data back out to another topic, right? So it's a consumer and a producer. The difference is you also have access to this thing called the DSL. It's their domain-specific language, but it's sort of simplistic. You can do joins. You can do things that you can conceptually think about that are sort of similar to a database world, right? Down below that, they have what's called the processor API. So it's way down here. It is super complex because you can control what happens as data frames come in. Like you have full access to everything. It's way harder. But then up here at the top, you have this thing called KSQL, and everybody coming from a relational database background kind of knows SQL. It's pretty easy. Standard joins, that kind of stuff, right? So if you want to be super productive, you can do this, but the amount of functionality you get is fairly limited, but it is good for some use cases, and I'll show you that here in a minute. So all that said, that's the background on what Kafka provides in terms of streams, and I'm going to show you what I'm going to demo here today. So I'm going to have a SQL Server, an ElasticSearch, Kafka Connect. As a matter of fact, let's talk about that real quick. Kafka Connect is a service. And really all it is a consumer and a producer. And what it allows you to do is instead of when you set up your SSIS package, you say, hey, I want to go to server 2 and I want to go to server 3 and all that kind of stuff, this is configuration based. So there's a lot of consumers out there, or what are they called? Connectors out there that allow you to connect to JDBC databases, Google Cloud, to AWS, to Azure, whatever, right? So there's all these connectors that are configuration based. And I'll show you a couple of those here in a minute. But it allows you to basically just say, hey, I just want to pipe data from here to here. That's it. I don't want to have to set up a bunch of complex stuff. That's all I want to do. All right? So let's talk through this here. What we're going to do in this demo is I'm going to write a bunch of transactions to the database, right? And as things go into that database, I basically want them to then go to this Kafka connector that I'm going to say, hey, watch these tables. And when data hits those tables, I want it to then go into some specific topics that I set up, right? So the whole point here is it's configuration based. I'm not writing a bunch of code, right? And then after that happens, I want these two things over here. I'm going to have a KSQL server running, which is nothing more than a K-stream application that can support this SQL language on top of it. I want data to go to there, and I want it to go to here, right? So all these guys are doing is subscribing to that topic in Kafka, right? Then, like I said, the important part is you're probably not just going to listen to data and not do anything with it. So after you do that, I'm going to have these things feed data back into a new topic in Kafka, right? Once that happens, it's going to go back through another connector that I've configured. And once that happens, then it's going to go push data back into SQL Server and into ElasticSearch. So the whole point is, instead of having SQL Server do things like, if you have a bunch of orders, so what I'm doing is like a user rewards type thing, right? So you have a bunch of transactions that come in that have values associated with them. In the olden days, the way people would do this in the database is they'd write a group by and sum and all that kind of stuff, and that's all fine when you have 1 million records. What happens when you get to 20 million? You know, like anybody that's worked in SQL Server or any database for a long time, everything's great until it's not, right? And it might just be that one extra record, and you're like, well, why did it go from 2 seconds to 10 minutes, right? So the whole point is offload that work onto things that are distributed that can do it on their own without requiring something like SQL Server, which notoriously is scale up. Add more hardware, add more RAM, add more drives, add all this. These things over here scale independently. You add as many nodes as you want, and it just scales that way. So that's what we're going to do. And so now we can start the demo. All right. So hopefully this goes a little bit better than what the video did. All right, so there's quite a bit of just, I'm not going to show you a ton of code. I want to show you the results of the code, but I'll point out some things as we go, right? Let's see what time it is. All right. So first thing we're going to do, anybody in here work with Docker? Okay, quite a few. Anybody work with Docker Compose or know why? Okay, excellent. So I'm not going to go deep into it, but everything that I'm going to run is running in a Docker Compose setup, which means that I'm basically going to spin up about 6 or 7 different services or servers on my machine with one command, right, which is kind of nice. So right now, you'll see here, I'm creating a SQL Server instance, Kibana, ElasticSearch, so that's the Elk stack. Zookeeper, which comes with Kafka because this is what keeps everything in sync. The broker, which is actually the thing that stores the data, is what that takes the data in for Kafka. Schema registry, that's kind of interesting. When you are doing things in Kafka, you can use the schema registry, which means that as data comes in, you can type it, right? So it's kind of nice. You can store it there. It can create a whole world of problems, but it can also save a world of problems. You have Kafka Connect, then KSQL Server. Like I said, that's another service that runs. And then Control Center, that's so you can look at the Kafka stuff. It's something that comes from Confluent. It's nice to be able to show you what's in there. KSQL CLI, and then DataGen. All right, so these things are running. What I'm going to do now is I'm going to connect to the SQL Server. And I usually use SSMS in my regular day stuff. But Azure Data Studio, if anybody doesn't know, here's a nice little tip for you. It's cross-platform, so if you're on Mac, if you're on Windows, if you're on whatever, you can run this. It uses like the same type backend that Visual Studio Code does, and it's really good for presentations because I can increase the font, that kind of stuff, right? So it is a nice little tool. So the first thing we're going to do here is we are going to create the database. The only thing that is a pain about this is it doesn't save the connections for each thing that you do. So that thing's created. I've now created a database called StreamingDB, right? The next thing I'm going to do, and we'll talk through this here real quick, it's not all that interesting other than just knowing what's there. So I'm creating these tables, and really I've got this user rewards table that's really just your balances, right? That's all it is. So if you think about if somebody's going to come up and they're going to shop at the rewards points, you don't have to sum up all the transactions every time. So that's your ledger, right? Or not your ledger, that's where you're storing the aggregates, right? Then you're going to have the transactions. This is where the data streams in and out. And it is hot now, so this is coming off. So you're going to put your transactions in there. And then this one, this real-time one, is where I'm going to bring data back from Kafka that I compute and aggregate on the external things so that I can spin up as many workers as I want, sort of. I'll tell you why in a minute. All right, so that's created. Now the next thing I'm going to do is I'm going to seed some of this data just so I can have some beginning balances. Nothing really all that interesting here either. But I do want to show you a couple of things here. So you can see here, the balances, that's fine. This is the interesting part. So with Kafka Connect, if you're using the standard JDBC connectors, they have this thing that says, hey, you can watch a particular column to find out when data changes, so I know when to go get data out of SQL Server and push it into Kafka, right? Well, what kind of stinks about that is if you are updating things, what are you going to watch, right? You could do a date stamp if you wanted, but that's kind of heavy-handed. There's a thing in SQL Server called row version. If you had a column like that, it automatically, every time a record's touched, it increments it, right? And so what I'm doing here is I'm just converting it to a big int, more or less just I think I have a computed column on the table. And so every time that connector sees that number go up, then it goes and pushes that data over to Connect, right? A little bit of stuff that is painful until you realize what's going on. All right, so now, what I'm going to do, and this is way more convoluted than what it needs to be, but really, I'm just creating a slow loop so that I can show you what's happening, right? Because it wouldn't help you if I'm streaming a million events and all you see is just stuff screaming across the screen. So this is basically just inserting data into this transaction table every half second, couple second, whatever, like on a random thing. So I'm going to run this, and then we'll get started on the other part of it. All right, so this thing's running. We will see, as a matter of fact, if I come here and I say, actually, let me double click it. Okay, that other one's still open. So if we come up here and we connect and I run this one, so this is kind of like the thing so that we can just see, hey, what's actually going on behind the scenes. And so in fairness, this is kind of what people would do in the past, right? When they're trying to get things out of SQL Server, they're going to go run a bunch of aggregations, right, against the live data. And this is what I was talking about. Like, this is all fine and dandy until you reach that point, and then all of a sudden these queries no longer come back in time, and then people start thinking about, oh, well, maybe we need to batch these. Maybe we need to put them on some sort of schedule, whatever, right? So this is what we're trying to avoid. But it's good for being able to see what's here. So a couple things I want to point out. I've only got 9 users. Right? I didn't want to go too big. And then over here, you'll see that I'm calculating the point balance. That's coming from the query above. That's doing the aggregations. The streaming point balance is coming out of that real-time table that I set up. No data's in there yet because I haven't actually hooked up anything, right? And then same type thing over here. So I've got the points redeemed. I want to keep track of how many people are spending. So that's right there. And again, this is coming from the other table. Nothing in there yet. So just in a nutshell so we can see here, and then I've got the counts of transactions. Now, one thing that was frustrating when I set up this demo is if you've ever tried to set up a query that will do random numbers in SQL Server, it doesn't work well if you're doing it in a single query because you have to reseed those values every time. Even with the random thing that I get, the distribution's not great. Everything, like at the end of this, I'll have 27,000 records in one of these, and I'll have 26,800 in another one. So it's not perfect, but it'll demonstrate the purposes. So now it's time to start looking at Kafka. Now, one thing I will tell you about Kafka is it's not the sexiest thing in the world. There's not a bunch of UIs behind this thing, right? So it's not like SQL Server where you go in and you just start doing things and everything feels glorious, right? You type in a query and it comes out. It's not like that, man. If there's one downfall to Kafka is there are not great UIs around it. Most everything is CLI driven, which great for scripting, great for automating, not so great when you're actually just trying to see what's going on. All right, so the first thing we want to do here is I'm going to set up topics. Now, something I want to point out to you, and maybe if I can make this a little bit bigger. Oh, that's a little bit too big. So you'll notice up here, I've got partitions set to 5. This is really important. So I said that you can scale out applications with Kafka. That's only true based on the number of partitions. So if you think about it, when you set up a worker, a K-Streams application that wants to work on data, it works on one slice, so one partition, right? So if you want to have multiple workers stood up running, then you have to increase the number of partitions. So for the demo, I've done 5 because you'll see some interesting things that happen here. But that's important. If I hadn't set this up front, set up the topic with the partitions, whatever starts going to talk to Kafka is going to create it with their defaults. And this is another frustrating thing is everything has their own defaults. KSQL does 4, some things do 1, some things do 5. And the problem is when you start trying to join data across partitions or from different topics, everything has to have the same key on the same partition. So if you start trying to join something, if you have 3 partitions in one and 4 partitions in another, and you try and join user ID 1 from this one to user ID on that one, it might be on partition 1 over here and partition 2 over here, and it's not going to work. So you have to use the same key hashing method going across these things when you're setting them up. That's another key point. A lot of you are .NET developers. If you start playing with this, know that out of the box, the .NET producer is not the same hashing algorithm that the Java ones are. So you'll be looking at your data going, why is this missing? And it's because it put it on a different partition because it's hashing the data differently. So know that when you're putting data up there, if you're using different languages that have their own libraries, pay attention to that. All right, so now what we're going to do, we're going to go run this. I'm just calling the Docker compose. All I'm doing is calling the shell script that is inside the broker itself, and I'm passing this in. And it's going to create the topic. It gives us a warning. All good developers ignore warnings, so don't worry about that. The next thing, and I joke. I think at my work we have a project that has like 5,000 warnings, and it's all SQL Server-based stuff, and everybody's just giving up hope. All right, so created that one and this last one. All right, so trust that these are there. We're going to go look at them in a second. There's no data in it. They're just set up, right? So now what we're going to do is I actually am going to set up a KSQL client. So this is about the best UI you're going to get in Kafka, which is sad. So what you're going to see here is the KSQL UI, right? It's amazing. So what this gives you the ability to do is run queries at the command line. And we're going to step through these. And here's a super important thing right here. This auto offset reset earliest. I'm going to show you what it means in a minute. But know that if you're trying to run data, if you're trying to run applications against Kafka, I think by default, most everything says, hey, I only want things from now. Right? So if you want to go back and get everything that was historically put in those topics, you better set that. Otherwise, you're going to be saying, why am I missing all my data? So this right here is imperative in most cases when people are trying to set up things. Oops. So let's drop this in here. Tells us it worked. We'll trust that. All right, so now here's where we're going to start getting into some pretty stuff. So I'm going to drop this in and then we'll go talk about it. All right, so if we look at this thing right here, all we're saying is we want to create this table called user rewards in KSQL, okay? Behind the scenes, that's actually getting stored in a topic in Kafka, okay? Here's the really important thing to know in every single person I've worked with on streaming applications, especially with K-Streams and Kafka, they see table and they think it's actually a table. That's not what's happening. Everything in Kafka still gets stored in a queue. The only difference is it's a practice, it's a standard. When you use a table, you're saying that every record in there is the current state, okay? So instead of like transactions rolling in with I paid $10, $5, or £3 or £5 or whatever, this is the customer has spent 15 pounds total. You have to think about it like that. It's up to you to make sure that that's what you're doing, all right? But that's the assumption. So all I'm doing here is I'm saying, hey, back it with this topic that I just created a little while ago. Currently, there's nothing in it, right? So there won't be anything in that table. So the next one I'm going to do is a stream. And this is exactly what it sounds like. These are the actual transactions. So if we drop this thing in, you'll see here, I'm pointing at the transactions topic, right? That's what I'm going to fill up with the individual transactions that come across. And a stream is exactly what it sounds like. As data hits, this thing will start picking it up and doing things with it. So it makes things nice. All right. And then the last thing I'm going to do here is I'm going to set up this user rewards balance table, right? And I think I named it pretty poorly. I called it RT balance, like retweet. I meant for real time. So that's all that's going to happen here is this table is going to have information in it. Oh, here's another key thing. You'll notice I have the format as Avro. It's not super important for you to know about right now other than just have it in the back of your head if you start playing with this. So I don't remember what talk it was earlier this week. People said, you know, JSON's great for human readability. It's terrible for data compression because you're repeating the properties, the names, everything over and over and over, right? Avro strips that out for you. So that's when I said that you have the schema registry. The schema for a record gets stored up in that schema registry, right? So in this case, I've got user ID, points, description, that kind of stuff, right? That way, when the record comes over, it's probably in some sort of array. It's in a binary, but it's probably in an array format, right? So instead of, user ID :1, it's going to store this thing in a way more efficient format that's going to be faster and more efficient, right? So just be aware, Avro is kind of like the de facto standard with this stuff. So that's that. All right, so now, here's the interesting thing. Let's get into where we can actually look at some data. All right, so keep in mind, this is a streaming application. So what you're going to expect to see here is data just continually coming in, right? It's not like a SQL query where you run a query and you get your result set and it's done. That's not how this works. But nothing's coming out, right? Well, nothing's coming out because we haven't hooked up SQL Server to Kafka yet. There's nothing that's piping the data across yet. So that's where we're going to do something else. And you'll notice I have a few tools open. So Postman, all it is they've basically got the connector has a REST API endpoint that you can call, that you can set up connectors, destroy connectors, all that kind of stuff. So that's what I'm going to do. And this is where I was telling you that it's all configuration based. Now, a couple of key things to talk about here is you'll notice that I've got sources and sinks. When you're talking about in the Kafka world and probably a lot of the big data world, a source is where you get data from. To put it into Kafka, a sink is getting data out of Kafka and dropping it somewhere else, right? So that's their terminology. So here's what I'm going to do. I'm going to set up this user rewards connector, and this is the configuration. It looks like a lot, but it's really not. It's a bunch of boilerplate stuff. But more or less, you're going to have your connector to the database. You're going to have the connection over to Kafka, so you're going to have to tell it like where the broker is and all that kind of stuff. I do have some interesting things here called set schema, create key, extract key. That's actually doing inline ETL transforms on a per field basis. So on one of these, I don't remember which one it was exactly, but on one of these, I actually have to convert a date time string into something that will be recognized in Kafka as a date time, right? So you can do some of that stuff inline here. You'll see here, I have this poll interval. So this one I think is set to the max, which I don't even know how long that is, but all this means is I want this to grab this data once, more or less, right? The way Kafka Connect works is you set it up on a polling interval, and so you can tell it, hey, I only want new data every 10 seconds, every minute, whatever, right? It's up to you how frequently you want it to get that data and push it back over to Kafka. So that's where you control that. So this is basically what you do for both the sinks and the sources. It's really easy. So I'm going to set this one up. If everything works, then I should have down here, you'll see this came out with the task, right? So I'm not going to show you the other one. It doesn't really matter. It's the same thing. We're going to hit send, and it echoes it back anyway, so you can see what happened. And I'm also going to set up these sinks here right now. So we'll do this because these are the things that are going to push into the database, and this is the one that's going to, I probably should have waited to see if that finished. And then this is the one that's going to push into Elastic, right? Now, we should have data coming across. Check this out. So what happened, because I set this thing to auto offset earliest, it went back to the beginning of everything and it went through it all. And so as new records come in, we're going to see these values change. Again, this is a live streaming application. This isn't a query that's running against some fixed set of data. This, as these things come in, as they're being written to my table, they're being streamed across to Kafka, and now I have access to that data in Kafka. Now, a couple of key points here that are actually really important when you start messing with Kafka. These first two fields, that's your timestamp of when it came in. You have control over that. You can tell it what the timestamp is, and this is the key for the record. If you start messing with Kafka, use a string as your key. Don't mess with anything else. You will lose days. You will lose sleep. It's not fun. I've been there. So that's important, and the things to the right are the values that are coming out of that, right? So that's cool. We have data coming into Kafka now. Now, one thing I want to show here is if we go to 9021, so this is the control center for Kafka. And when I say that UI is a challenge for these people, I'm pretty sure a high school kid did this stuff. So here, it's so awful. I can't even explain how bad this is. All right, so here's the important part. I can't make it bigger because everything will disappear because their UI is awful. Just take my word for it. These are the topics down here. You'll see that there's data coming through. You have throughput. You'll see the replication factor on these. Did I set those to 5? That's interesting. Oh, so they actually they misinterpret this. These are the partitions. I have 5 partitions. That's not actually replication. It's 2 different things in Kafka. You can replicate to the number of servers you want, and you have partitions, right? So 2 different things, bad UI. And they're lying about the partitions here. So at any rate, you see that data's coming through. We have these things in here, right? It's nice to be able to do a sanity check, more or less, right? That's the only reason I ever come to this page. All right, so now, back to the next bits of this. So we took a peek at that. Now what we want to do is we actually want to start aggregating things. So here is where I'm going to have KSQL do these aggregations as they come in. So let's paste that. All right, so you can see here, it's pretty simple, right? It's basically what we did in the SQL Server query. I'm going to say, hey, give me the max points redeemed, and then I'm going to sum the points, and I'm doing the negative one because I want it to be a negative value as it comes in, right? Or I'm actually inverting it because they were all negative, so I'm basically, I could have done the absolute, whatever. So that's coming in as points redeemed, right? I'm doing the aggregations in KSQL so that this stuff goes into a topic, and then that's probably already being replicated back to SQL Server now, right? So let's take a look at what this thing looks like. And what we're going to do is we're just going to look at one user. So this is where I said the important part is, man, that stinks. So look at this. I have where user ID equal 8, or user 8, right? Again, this doesn't go to a specific row, right? When you run this query, it's going from the top of, or the bottom of that stack all the way to the top. So what we just saw stream out of there, and this is super important to know because every single person that sees Kafka and they're like, oh, this is amazing, let's replace our server, our database. I'm like, no, don't do that. That's not how this works, right? So this is going through the entire stream. And as new data comes in here, you're going to see it pop on because, again, this is a live, breathing data stream. So the last thing we're going to do here is I'm going to get those two fields together that I talked about. So the points redeemed and the actual total number of points that you've earned, right? Or spent or whatever. So that's it. These things are all going into topics now. So now it's time to go back and look at what we've got over here. So I think I'm pretty good on time. So remember, these are null because there was no data in those tables, right? And I think I actually kept this thing alive. Let's connect. Just so you can see, again, right? Let's do that. So all I'm keeping in this table is the balance, right? The totals that are going on. So as data comes across that are now being processed externally on scalable infrastructure, that's happening and then coming back and being fed right into SQL Server, right? These are super lightweight updates as opposed to running these aggregations all the time to find out what you want. So like that top one right now is 81,356. It's different now, 81,421. It's constantly getting updated, right? And I could have it on whatever polling interval I wanted. Now, if we go back over to, it was this one, and we run this again, here's the cool part. This stuff is happening. Now, granted, I have this stuff trickling in. I'll show you a fire hose blast in a minute. But look at this. The point balance is the same on these, 10432. The streaming points redeemed is the same, 2256. Now, we might see some discrepancies down here as it's trying to synchronize data, but I don't see any right now. But that's because it's basically keeping up with everything that's happening. I don't have a lot of data going through there right now, but that's really important. So that's cool, right? I didn't do a whole lot that you guys saw to make this happen, right? I now have something that's streaming this data all the time. Forget that this was nights and nights and nights of why isn't that working, why isn't this working, right? So this is a template to start from if you ever want to try this stuff because I have all this up there on GitHub. Like you can truly go run it. I've tried to put out a README and stuff. So if you want to follow this and play with it, this is a good way to get your feet wet. So that's all working, and that's pretty awesome. Because now you have stuff coming in real time. But the really cool part is I have this going to multiple places now. Which in the past, like I said, when you have things like SQL Server and that's what you're using for everything, if you wanted to push it into another place, you're going to go set up another SSIS package and you're going to set up all the same type stuff. Hey, I want to push this there, this there. It's a lot of work. So what I'm going to do here is nothing all that glamorous, but we're going to look. So you'll see here, I have this index down here. This is when I set up that sync connector to push into Elasticsearch. It's pushing it into that index. So I am by no means a wizard in Kibana or Elasticsearch. You don't have to be that familiar with it. Just know that this is really cool that this is happening like this. But what we're going to do, I didn't hit save. Source. So you have to, at least in here, you're supposed to tell it a timestamp. This is the thing that I told you I had to transform in to convert this to a real date so it wasn't a string coming in. And it's basically so you can create these index patterns. So this is going to create it. Now what we'll be able to do is we'll be able to go look at this data and inspect it, right? So if we come over here to Discover, check this out. I now have a dashboard of all the transactions that are coming in. And all I had to do was set up a configuration to bring this in here. Good luck doing that with much of anything else, right? So this is really cool because now if I put really important data in there instead of just these transactions, I could do some interesting things, right? Like maybe I wanted to create dashboards, maybe I wanted to search. So I could come here and I say, hey, I don't care about the points. Let's look at what's going on here. So I'm going to say visualize. And these are all the points that have been coming in, but this isn't really all that interesting because it's not broken down in a way that makes any sense. So what we're going to do is we are going to change the x-axis to be by significant terms, and we will make this the user ID because that makes a lot more sense. We'll put that at 20. Oh, I actually don't want that. I want terms because then I can order it. So I'm going to make this one user ID keyword. I'm going to make it ascending so that we can see all these things. And we only have 9 of these. Okay, that's fine. And then up here, I actually want to change this. We'll keep the count there because that's interesting. Let's add another metric though. So that's going to be the count of transactions we got for the user, right? That's what we're going to be looking at there. And then here, I'm going to say, you know what? I want to see the sum of points that came in. So I'm going to sum this, and I'm going to choose the points, right? And now, one other thing we want to do, if I run this right now, I hate stack charts. I can't stand them because it seems like data gets lost in them. So what I'm going to do, just for kicks here, is I'm going to set these things up to where they run side by side. So instead of stacked, we'll do this. And now, if I mouse over these things, you can see, hey, user 1 has 106 points that came in. And I can search that stuff. I can do a lot of interesting things if I put a lot of data in here to where I can go start doing, like if you're in Kibana, you could even do machine learning, right? Like, is there anything that's anomalous here? Is there anything that I should be aware of? Whatever. But the key is you dump that data out over here and you can visualize it, right? And that was all through a few configurations. So that's all cool. Every time I show this stuff, one caveat I have to put out there for KSQL is, when I told you that your functionality goes down, it really does. You can do simple things. You can do joins, you can do aggregations. But if you need to do anything that's really parsing data or anything like that, or needing to reach out and do other things, it falls on its face super fast. And that can be frustrating. So the last thing I want to show you here is, it's actually kind of cool. So first off, I need to open up something. And this is magic, by the way. I just figured out how to do this the other day. So if you do this, watch this. Look at that. I have that whole thing come up. That's amazing. It's the little things in life. So don't worry about the fact that it's really small right now because I'm going to point out the certain things that you should care about. But first what I want to do is I want to walk you through what this is. So a K-stream app is Java. I personally hate Java. And when I say hate, like I can't, there's a certain level of hate that I can't even go to. I don't like typing out string every time I'm going to do a string, right? Like I've fallen in love with C# and how short the code syntax is. So if you're like me, if you hate something enough, you'll find a solution to it. And the solution is JetBrains created a language called Kotlin. It compiles down to the same bytecode that Java does. It's amazing. So the syntax is very, very similar. So the thing is, basically, when I went to do this, I took my Java code that was working, and I right-clicked it, and I said, convert to Kotlin. And that was it, right? So if you ever find yourself in the Java world and hating Java, know that Kotlin could be your friend. So let's take a look here. It's actually not that complex. What you're going to see here is, like with a lot of code, most of it's boilerplate. So the main method here, this is the application that's going to run. And here's the important part to know, too. This K-stream application could run anywhere. As long as it can connect to your Kafka broker, it could run on a laptop, it can run on a server, it can run in Kubernetes, which is how I do it. Oops. Sorry about that. You could actually have this thing run anywhere as long as it can connect. So truly, this is distributed, and you can do your compute just about any way you want to. So with this, back to this, the transform streams, that's nothing important. This load environment variables, all that is are the properties that I've set up for it. It's the connections. You have the app name up there, which is counting apps. Really, this is, again, boilerplate, nothing all that glamorous. The stream properties, this is where I'm just setting those development environment properties to those parameters for Kafka. This is where the work happens, in this build topology, because everything in Kafka is called a topology when you're doing this in the K-stream world, because it says, okay, I've got something that's listening to this topic. After that, it transforms over here. So it kind of draws out this graph, right? That's really what's happening. So up here, what we say is, I have this input topic. I got that from the development thing. That's the transactions coming in. It might actually even tell me. I don't know. Down here, so you have things coming in. Now, here's one thing that really kind of stinks about it is, I think, Steve, you were talking about the JSON serializer stuff, right? So one of the things that's really, really irritating is if you're going to work with data in Kafka, you've got to marshal that data in and out of objects, right? Otherwise, it doesn't know what the types are. So everything you do in Kafka has what's called a serde. I don't see it. This is basically what it is, though. So basically, when you define it, you have to tell it what type the key is. Again, always make it a string if you care about your sanity. And then you're going to have another type here, which this is something that I've defined in another Java class. It's a simple boilerplate type thing, right? So basically, data is going to come in here, and then I'm going to say group it by the key. I want to do it by the user ID, which is already the key on the data. I'm going to group it by the key and get the count. And then I do another thing down here. I have to turn it back into a stream. So up here, you'll see I have a K table. So again, when you do the group by key, it's giving the latest value of what it is for that particular user. But then if I want to be able to do and push it back out to a topic, I have to turn it back into a stream. There's a lot of just redundant code that you do in these, but you have the full power of Java. If you need to reach out, like where streams start seeming really interesting to me is if you have machine learning models or something like that, and you want to apply that last calculated model to every record that comes in, this is where you do it, right? If you have certain business logic that needs to group and bucket things, this is where you can do that kind of stuff. And again, like one of the use cases we have is we have IP validation, right? And if you've ever looked at IP validation, it's not fun. There's Java libraries for that. So you can just include that library, use it, and then you just go on about your way. So all that's happening here is this stuff happens, and at the very end, you'll see there's two things that are interesting to us right now is you'll see this print function. This print function is what we're going to see come out on the console here. That's going to slow things down, but it'll allow you to see it. And then the next thing is I'm going to take this data, push it into a new topic, and I'm going to take that data, and I'm going to push it into another topic. Now, we're not actually going to go look at those topics, because that's not what I want you to see. What I want you to see is how this works when they're parallelized. So now it's time to get into the fun stuff. This is the part that everybody asked about every time I did this demo. And I was like, okay, I guess I need to figure out how to show this. All right, so the first thing we're going to do is we're going to follow the logs of the Kafka broker. So what I'm doing here is I'm looking for the word rebalance, all right? Because what's going to happen is every time I online another instance of this stream app that is going to work on this data in parallel, the broker's going to start rebalancing itself to say, okay, I need to put more work over to this one, more work over to this one, and this one, right? So we want to see that happen. So the first thing I'm going to do is I'm going to start up this jar. So I've already compiled this thing. So check it out. This thing's starting up, and cool. This thing came up here and it said, hey, I see something new came up, and it's starting to push data over to that, right? Now, one thing I want to show you here is this is really, really, really key here. And if I can zoom. Really? Huh. Okay, I guess I'm not going to zoom there. So that's technology, right? So here's the key parts. I told you we have 5 partitions. This one says the current active tasks are partition 0, 1, 2, 3, and 4. This thing's got all of them, right? This one worker is responsible for handling all the data across all partitions. This is where people go, holy crap, this is amazing, because now, hey, this thing's getting bogged down. I need to spin up more workers, right? And in a world like Kubernetes, you set up the thing and say, hey, if the CPU utilization goes bonkers or whatever, just fire another pod up, right? That's what you're going to do. And that's what we do in the real world. So if I do the same thing here, say jar, I run it. Now watch up here, top left. Sees that we have another one. It's rebalancing. Now, check this out. Let's go back to this. So that one's frozen there. and you can see this one. This one's rebalanced. Now it has 0, 1, 2, 3, and 4. No, wait. I stopped it. There. This one now has 0, 1, and 4. This one has 2 and 3. So it redistributed the work for everything. So now, as you need more processing power, you have the ability to do it just by starting another thing because it knows its application ID that it registered with the broker. The broker says, oh, okay, I have another worker. I'm going to put you online. Now, what's interesting and not obvious to a lot of people when they first start getting into this is we're going to spin up a bunch of other ones. All right, and what you'll see is some of this data will start disappearing from some of these other ones, right? So now this one's responsible for 2 and 3, and this has got user 7 and 1. This one has user 2, 6, and 3. This one doesn't seem to be doing anything yet. Kind of doesn't make sense, right? It's got partition 1. So here's the thing that's interesting about this. Remember, I told you it hashes data as it goes into Kafka. If it hashes the key and that key doesn't land on partition 1, no data ever lands there, right? So this is an important thing that people need to understand when they start working with a lot of big data is some people say, oh, well, let's just partition everything and put all the customers on one. What if you have one customer that gets 20 million records an hour, another one that gets 1,000 an hour, right? It doesn't make sense. So you have to find a partitioning scheme that makes sense for you, but the key here is nothing's going to this one. Because when it hashed that user underscore 1, user underscore 2, when it dropped it on a partition, partition 1's not one where any data is going to go. But here's the cool part, right? So let's go ahead and fire the rest of these up. So it's going to redo that up there. All these are going to redo themselves as well. Do the same thing here, right? So at the end of all this, you might have one of these things just sitting idle because it's like, hey, I don't need it, right? Don't need it at all, not going to do anything. Some of these are getting data in, and you can see the ones that are doing it, and then the other ones are basically just sitting around doing nothing, right? But the cool part is, let's look at this one up here that's actually getting some data, and let's kill this one, right? Now, the broker is going to see that something came offline. It's going to redistribute everything, and now that data gets picked back up and works. And the way Kafka works and these streaming apps work is they work off what's called offsets. So you don't actually lose anything. So if this thing dies in the middle of whatever it's doing, it was managing an offset. I had record number 100, right? And it writes that back to another Kafka topic. So all that data is stored in the broker. So if that thing dies, when something else goes to pick it back up, it says, hey, let's start at record 101, right? So all this stuff happens for you automatically just by using the framework. So that is a vast majority of what I have there, and I think, yeah, I left right at about 10 minutes for questions. So, oh, no, I didn't. I left 3 minutes for questions. All right, so that's it for that. So if anybody has any questions, obviously, oh man, whatever. I'm not messing with that. All right, so there's that. So anybody have any questions about this? It's a whole lot, yeah.
So if you start out with a certain sort of hashing and partitioning, and you realise that you've got it wrong, because like I say, one customer actually just turned out to be doing 20 times more traffic, how much of a headache is it to change your strategy? Do you have to drop everything and start again, or can you change without losing anything?
No, you're not going to change without losing anything. You're probably going to end up recreating and then piping that data over to something else. I mean, being honest, like one of the things about Kafka is it's very efficient at what it does, but there's not a lot of tooling around that kind of stuff, right? Like you can delete topics and you do stuff. You can repartition topics, but if you want to change the repartitioning scheme, then that means your applications have to be aware that, hey, what the partitioning scheme used to be just changed, and so now it's going to be on you in the application side to manage that. It's probably not worth it. It's probably better to move that data, take it offline for a minute, move the data, get it in the partition scheme you want, and then that way your application logic doesn't get complex, right? So that would be my suggestion. And for people who couldn't hear him, he was basically saying, hey, if you realize that you partitioned and you hashed your keys wrong, how easy is it to move over to a new way of doing it? It won't be. So you'll probably want to reset up those topics with the partitions and the hashing that you want. Anybody else? No? Yeah.
So you said towards the beginning that .NET hashing algorithm that's used with Kafka is different to the .NET algorithm, to the Java algorithm for hashing with Kafka? Is that the actual hashing in those frameworks, in those systems, or is it just the hashing algorithm that's used by the Kafka code you pull in for them?
No, so the question is, when I mentioned that .NET's hashing algorithm that they use by default is different than the one that Java uses by default, are they just different implementations? No, it's actually the same stuff. So I forget what the exact name of the one is. It's something random is what Java uses, and the one that .NET uses is something else by default, but they have the same base set of algorithms. You can make your own. You can make your own hashing algorithm that you want, so you can put your data on the partitions you want. No, they just selected a different one by default. So almost all the libraries that are out there for consumers and producers are the same C++ library that was written that are wrapped for the different languages. So if you're doing Ruby, .NET, any of those, it's the same underlying code. They just have their different wrappers, and whoever did the default for that didn't do the same one that Java did. So that's it. Yeah?
I might have misunderstood this, but the query that's pulling the data from SQL Server, is that reading the whole table every time it polls?
So no. The way that works is, and you know when I showed you the row version or whatever, so the query I put in basically said, hey, look for this particular column. And so what happens is I have a query that says, hey, select everything from the table where this field is newer. And so behind the scenes, the Kafka connector is always storing the latest state for what it got for that field. So if the last record number it got was 100, then it's only going to say, hey, where greater than 100. It's doing it for you. Yep. So you index that field, absolutely. And there's another thing too, is there are commercial connectors available. I'm using just the JDBC one for this, but there's one that has change data capture specifically for SQL Server. So you can even hook it up nicer and just say, hey, every time something happens, fire it off, right? There you go. Okay, so you would probably do something very similar to what I did here. And if anybody was, I forget, you probably can't hear. So what he asked was, is this thing pulling the whole table every time, or is it just grabbing the latest records? It's grabbing the latest records because of the configuration I put in. Anybody else? We good? All right, awesome. Well, thank you very much, and enjoy the rest of the day.